On this episode of Pipeline Things, we welcome a return guest, Rienk de Vries, back from Intero, when we talk about the developments that they are making in the difficult-to-inspect robotics space. Super cool space with lots of room to play, and we talk about why brisket is better than pizza. It's a great episode, and we think you'll love it. Thanks for joining us. All right, welcome to this edition of Pipeline Things. So we, again, Miss Producer always tells me not to date the episode, but truth is we are fresh off of PPIM 2026. It was a lot of fun, and if you're there at the show, you know it's always a good time to catch up with what's going on with the vendors. It's a good time to see friends in the industry for sure, and kind of like what's shaking, what's going on. I like that you kind of get that annual update. So one of the presentations I was in, Chris, and I thought it was funny. It made me chuckle a little bit. The key takeaway on the presentation was this technology is just as good as it was in 2007, and it does the same thing. And I was like, oh my God, did I just hear that the technology is just as good as it was in 2007? And I laughed a little bit because I don't think that that's true of all the technologies, right? Like you've got technologies out there, thank God, that I think are actively developing and investing and being pulled on to do new things.
Being validated, leveraging AI because now they have data to calibrate against, all that fun stuff.
Yeah, 100%. Because So, and that brings us to, I think, who we're talking to today. So I think one of the cool spaces that remains, I'm going to say very lightly tapped, and I think just continues to have a lot of potential for advancement is really in the difficult to inspect market, the challenging market, if you will, and almost, I don't know if we could use the word unconventional. And last time at PPIM, we got the chance to talk to Intero, and it was pretty cool to hear some of the stuff that they were doing. And I will say, fortunately, I think they can quite proudly say that their technology is better than it was in 2007. I think they could say it's better than it was in 2014. It's better than it was in 2021. I think they could say it's better than it was in 2025. And that's really what we're here to talk about today. So,
and all the great work they're doing, right? I mean, we just finished posting failure files 2.0, and we know that Congress has been pushing, right, the PHMSA to continue to use inline inspection, to provide data, to do data integration and risk analysis. So it's always neat to bring on Intero to find out, how are they doing all the difficult stuff, right?
So without further ado, I'm going to go ahead and introduce our guest. Rienk is joining us again, Rienk de Vries from Intero. And Rienk, I just want to say welcome and thanks for coming back on the show, first and foremost.
Yes, thanks for having me again. I think it has been 2 years.
Yeah. Who put you up to this? Who
this
made,
time?
Yes. Who made you?
The last time you can remember, I was sort of a surprise guest,
right.
Unprepared.
A pleasant surprise.
Yeah. And you enjoyed it so much that you requested to come back on, or somebody like, no, look,
or now he got bait and
I
switched.
think
probably.
it was a little pull, but. No, but again, I think we enjoyed last time. We had a great conversation. I think we went a bit all over the place. We talked about pizza, but all about pipelines too.
Yeah. Look, I make no guarantees as to what will come out of the episode and pertains to non-inspection related things. So, it's the Wild West out there and what might come out today. But yeah, the goal really is definitely to talk about what you guys have been doing in Intero since the last time that we talked to you, right? And there have been some I am right. Y'all have advanced since 2007, correct?
Sure, yeah.
Okay.
Advancing every day. Sure.
Yeah, no. So the starting point was one of the abstracts that was there at PPIM was you guys worked with PG&E on the development of a long seam technology. So I tell you what, let's start there. I mean, that's obviously something that's pretty new. Can you tell us a little bit about what the genesis was that? How did you guys find yourself with a 10-inch MFLC tool designed to inspect for long seams and difficult to inspect pipelines?
It's a good question, certainly, and I think it's. Let's go one step back because the development of the entire what we call the robotic MFL fleet has been developed in close cooperation with the industry. And that goes back 15 years. I think 15, 20 years ago, this entire technology didn't exist. Having MFL on a robotic system, a self-propelled, wireless operated going into a live pipeline. There was really a desire from the industry to find solutions for difficult to inspect in urban area, high consequence areas, to inspect those complex pipelines. And since then, every development, every improvement of the tool has been done in close cooperation with the industry. And this one that we have presented here on the PPIM has been one of the latest developments. That's the what we call the long seam module. This time for the 10-inch has been developed together with PG&E for one of their pipelines that required inspection on the long seams. So yeah, close development together with the customer, but that's actually quite common for this type of solution that we provide to the market.
As a reminder, one of the things I think is really neat about you guys is y'all call it the Explorer tool.
Yeah.
Right, which is really cool. And one of the things you explained last time is it's, you guys have the pull unit or the tractor unit, and this is just a module that you guys can add onto that, right? And so it's not like you need a whole new design or a whole new development, but you have a platform that it's not modular, but it's kind of modular, right? You can just build something specific and attach it to the crawler.
And this is a good example of that. So the start of the development was basically the entire tool himself. So you have the driving modules. In the middle, you have in the center of the tool, you got the MFL-A, so just traditional MFL sensor module. And then on both sides, you have the traction units, and then in the front and in the rear, you have a camera and a laser. But the middle part, the AMFL module, you can replace it. That's basically what we've done now. Replace for an CMFL, specifically for inspection of the long seam.
So in this particular case, and I want to encourage our audience, I'd say go back. You can find it on D2 Integrity. You can find it on YouTube. You can search for the podcast with Rienk de Vries from 2 years ago. And I'd encourage you to go back and get, because we're not going to revisit the development of the tools. But one question I have with that, and man, there's so many places I want to go, but let me start here. Before I ask you about what that development cycle looked like, which I think is interesting, this unit replaces the MFL-A or it goes in conjunction with the MFL-A? So is it an either or in the case of the 10-inch technology, or do you have both on at the same time?
So we don't have both on the tool on the same time. So you really replace the AMFL module for the CMFL. So we have occasions where we inspect both for the same pipeline. So you do an AMFL run, then you go back and then you do the CMFL run. So you have two data sets basically of the same pipeline.
And that's not even uncommon. I mean, even normal pipelines. I mean, it's really difficult. There's like really only probably one vendor, Chris, maybe two that will put C and A in a train, just because of how much magnetic drag you pull on the tools.
Yeah, it's also environment, right? And even in those cases, it's maybe one of them is a little bit more conducive in a gas line, while the other is more conducive in a liquid line. And so here again, for this discussion, it's on stream in a gas line, right? So pretty much what we have as standard.
Yeah. And so, Rienk, what I want to ask you about is I'm kind of curious a little bit about that development cycle, because you mentioned you're working in close collaboration with the operators. I don't know that I think that's too unique in the industry. I think operators often come to the vendors with, hey, I have this problem, right? But I do think what is unique is that y'all's kind of bespoke solutions a lot of times may be unique even to only a particular operator that needs that particular configuration, which means that a lot of times I think the operators are having to really partner closer with you because they may be the only person that uses that particular configuration, for instance. But with PG&E and when they approach you, can you share a little bit about what the timeline to development looked like? Because I mean, I assume they didn't walk to you in November of 2025 and were like, hey, we want an MFL-C. And you were like, yeah, let me grab it off the shelf. It'll be ready next month. There's going to be a respectable lead time there.
Yes, no, for sure. No. So how this goes, we are working in close collaboration with the industry, as you said, and it's already shared. So the basis of that for developing more the resource side of the technology that we deploy is done together with NYSERDS. I think you're familiar with NYSERDS organization.
Yep.
You have a lot of members out of the gas grid operator environment. They bring money together and they subsidize development. So what we do with them is really the research part of the development. First prototype, in this case, for the long seam module. And then you develop one prototype for one size. And that was done back in 2022 for the 20-inch. And once that ready, then the follow-up very often is directly with an operator for a particular pipeline. So we have developed in 2022 the 20-inch. That was the first module.
So in 2022, that was an MFL.
That was exactly the same as the 10-inch from a technology perspective.
So it was an MFL
only a larger size.
2022.
Yeah.
Got you. Okay.
So after that, we had an inquiry for a 16-inch for another operator. So we converted it to a 16-inch, which is scaling down is always more difficult, obviously, than scaling up from a diameter perspective. And this was even more a challenge down to 10-inch. So when you already have the core technology developed and only have to do the up or down scaling for that particular module, that's a slower cycle, or that's a shorter cycle, obviously. So to give you an idea, you need to think about 6 to 8 months to develop then this particular model specific for the 10-inch for this case.
And then in that development cycle, do you find yourself, doing a bunch of like pull test and verification work on the tool? I'm assuming prior to putting it in the pipeline.
Yeah, no, of course, we do a lot of testing, in terms of the capabilities and the sizing capabilities, specs of the tool. We already have the experience, in this case, from the 16 and the 20-inch. So, of course, we have to reconfirm that when you develop the 10-inch on the test pools that we got. But there is a lot of testing involved. Yeah, you don't want to go into a live pipeline with a robotic tool without any proper testing.
So 2022?
22.
Yes.
Was the 20-inch tool. Then you got pulled to 16. Then you got pulled from 16 to 10, correct? And you said that cycle was about 8 months.
6 to 8 months, yes.
6 to 8 months.
That's pretty quick.
6 to 8 months to get a 6-inch tool? No.
No comment.
We do have a 6-inch robot, so in theory we could go down there and, yes.
It's got to be challenging to get the magnets. For an MFLC tool, it would be pretty challenging to get the magnets.
Yeah, so we only inspect the long seam area, right? So we haven't, it's circumferential, so.
So that's an important distinction.
Yeah, I was going to say,
absolutely.
that's what I was going to highlight is there something unique about it? Because in the paper, it sounded like, in the presentation, that you guys were focused on the long seam. So the organic question is, does it cover the whole pipe,
specific
or is
question
it the
here
long
was really
seam?
on vintage ERW pipelines, on the long seam area, because they are prone for challenges and threats. Yes.
Yeah. So
yes, that there. And then the next question obviously is, can you do it for the full circumference? Yeah, that's on the development roadmap, and can't say where we are there, but that's certainly something we look at.
Cool.
Yeah.
But even if you ran the current tool, I'm curious. This might be a dumb question. If it is, I apologize. If you put the tool in and you knew, well, you must obviously, the seams don't always line up.
No, we scan. That was in the paper presentation as well. I think was shown by Michael Kobelek, our sales manager. So we scan first with the AMFL, and from the AMFL data we can see where and locate and then go with the CMFL, so we can rotate it and get it in position.
But in theory, you could rotate the C anywhere you wanted to. If you had another portion of the pipe for some reason you want, like let's say you had a dent and you want to look at it.
It's slow, obviously, by doing that, but you could do that and then scan particular section full circumference.
Yeah, it's very much focused on the long seam. Is ultimately what we found out.
All right. So on that, the work that you did with PG&E, how did it do? What did you find? What did they find, I should say?
Yeah, no, we had, as you have seen in the paper presentation, we had a few long seam corrosion spots that we had found. And that have been back reported to PG&E. They were very pleased.
What I thought was interesting in the presentation is, I always like going back to how we got here, right? The why is always fun, at least to learn from, right? Looking back, you can learn a whole lot. And when we think about this application, it's you guys incorporate a camera in it, which I think is really neat. And so when we think about PG&E and we think about like what can we learn from them, we always think about San Bruno, right? And we know that the long seam was of detriment. And so it's not just this idea of it's a robotic technology, it focuses on the seam only, but I mean this is a very acute solution for a known problem that they had, where they had a consequence, right? They had incomplete welds in the seam. They didn't have an ability to assess it because it was theoretically difficult to inspect or unpiggable. And this is exactly like the result of a call to action, right? Congress said, we need to improve this. We need to be able to get better inspection techniques. And this is a manifestation of that. And in so much, apparently the weld was so bad, you could have been able to see it visually. Well, you guys have a camera on it as well. Yeah. Right. So you have an ability to, as you're inspecting with the MFLA, you find the seam, you get a camera to see if it's a complete weld, as silly as that may sound, how bad is the weld or good is the weld. And then you can come in and deploy it with an MFL to say, all right, is there anything that we can't find from the ID? So I think it's a neat
it's very
story.
powerful, right? Because if you look at it, you're mentioning the camera. Basically, we provide 5 data sets to the customer. It's the visual, the camera. It's a laser on it in front. You can see dance and out of roundness. It's the CMFL, it's the AMFL, and lately we have added the IMU as well for XYZ positioning. Yeah. So 5 data sets together provides you a lot of information.
Yeah, it's just a cool storyline for me, and I always like bringing that back up, right? It's how did we get here? Well, let's remind ourselves of the story, right? So this is cool to see.
So another simple question. You mentioned the XYZ. We definitely want to talk a little bit about that because that is a newer development as well. So I want to go there. But before I do, I have one more question. Just curious, from a magnetic standpoint, when you swap out the modules, from a power consumption standpoint, are the MFLC and MFLA roughly equivalent? Or are there any changes in power consumption between the two? Do they go the same distance?
Yeah, no, I can't. We do the same distance. Yes, okay. I think it's quite comparable. So it's not that with the CMFL you can do way longer distance. Power consumption is a limitation, obviously, of the system. If you look at determines the distance basically. We can talk about it a little more. So of course we look at possibilities to extend the range. Yeah. That's a big ask from the industry. Currently, we are limited to a certain distance. We have a solution. I think we talked about in the last podcast. Where you call it power charging. We can recharge the tool from external the pipeline, and then continue the range. But that still requires an excavation and a small hot tap. So if you can avoid that, that would be an enormous advantage. So we certainly look at that.
I think the biggest takeaway was it's not necessarily a strong change of the system, right? Yep. So as you're planning the operation component of we're going to be able to go from here to here, by changing the A to the C doesn't limit that right now.
No,
it's a
not.
1-for-1 right now. Is the takeaway?
Yeah.
That's great.
Cool. All right. So, well, I tell you what I actually want to do is we're going to take a brief break. I want to come back and I want to talk about the developments beyond that because I know that you already alluded to one, which is XYZ. And for the audience out there, they all know that I'm big on IMU and XYZ. So we're going to chat about that for sure. But I also want to chat about, some of the other things that you and I discussed about how and where y'all might get pulled in because I imagine there are other operators out there. Well, the needs in the industry aren't going to stop, right? And as I mentioned, it's kind of the Wild West and the difficult to inspect pipeline. So, audience, hang on. We're going to be right back as we continue our conversation with Rienk de Vries on developments in Intero. Thanks. All right, welcome back as we continue our discussion with Rienk de Vries from Intero on what's going on with the Intero technology and developments. So before we get in, there's one topic that we talked about on the last show, Rienk, that we haven't covered yet before, and that's pizza. Have you had pizza since you've been in Houston?
No.
Are you going to have pizza tonight before you leave Houston?
No.
Yeah.
No, but I had some good meat here in Texas.
Okay,
I think that this is not the place for pizza, right? Pizza, you need to go to Italy. Come to Europe, Italy, we got the good pizza.
Naples, for pizza.
Steak is the thing here, right?
And Tex-Mex, and margaritas,
brisket.
Yeah, I would agree. So, what's the best meat that you had? Was it a steak or was it brisket?
I think it was the brisket. Yeah, I love brisket.
Brisket is good.
It's good, that's not very common in Europe, right? Like there's not a lot of places to say.
I like cooking. I tried brisket during Christmas. It's dry. It's not.
It takes a long time.
I have done 7 on my smoker, and the first 6 were very weak. The 7th one, I think I finally got where I felt pretty good about it. I'm supposed to be trying another one next weekend, so.
It's hard.
It is.
You can have a recipe, but it's hard to make it taste good even if you have the recipe.
But the whole idea is, hanging around the smoker for 6, 7, 8, 9, 10 hours, drinking some beers with your friends.
Yeah. Absolutely. You got to watch it like a baby.
Yeah, he nailed that.
So, all right, well, then I'm glad that you got some good food in Houston because Houston is a great food community. Okay, so back on point. The last segment that we were chatting about, you mentioned a couple of developments that are coming down, one of them being IMU. So that one's super cool. Can you tell me a little bit about what was the pull on Intero to put IMU on the tools? Because my first impression would have been you guys are typically doing really difficult segments, but they're not that long, and so hence why you wouldn't have had an IMU on the tool. So how did you get pulled to having it on the tool? What was the driver?
Yeah, driver certainly was getting more accurate in your positioning of your anomalies. After we find an anomaly that need to be excavated, you certainly want to make sure that you excavate in the right position, not in the wrong position. And certainly because the areas where we inspect are in most cases urban areas. So it's expensive to dig a hole in the middle of New York, for example, right? It's a high price tag for permitting, traffic control, high cost. So the more accurate we can get, digging first and right at the right position saves a lot of money for our customers. There certainly was a pull also through the NiSearch organization, as you just mentioned. They use our tool and they follow the developments, and they provide also to us what you call the pull from the industry. And this was one of the requests to get more accurate on the positioning. So we have developed now the solution for the larger diameters. There you go again. For the larger, it's easier.
Yeah.
For this year, we are scaling it down for below 16-inch tools, which is smaller, obviously a bit more complicated, but that will be launched this year.
I'd like to know, why is it more difficult in the smaller diameters than the larger diameters? Is it space?
So you got just more space. Modules are larger. You can they'll accommodate more bigger equipment. So you need to reduce and resize electronics. It makes it more difficult for the smaller ones.
Now I'm also curious. So did y'all find it easy to integrate the IMU? Because you guys run it like y'all are not blazing speeds, and typically in free swimming tools we're running at very convenient speeds from an IMU standpoint.
No, exactly. So you might think indeed, I know you're an IMU fan. So
we're going deep. We're going really deep.
You get a bit deeper, no, but how difficult can it be, right? You just put an IMU module in your tool.
It's more difficult than people think.
But it is certainly more difficult, and also indeed because we have relatively low speeds. It's ideal for your MFL, right? Because you have higher, better data with lower speeds. But for IMU, it's get more complicated. But we fixed that.
How did you fix it, if you don't mind me asking?
That's not go into that detail.
No, but one of the things that is interesting, right? So, because you mentioned it, so I'll ask about it. Is the spacing of the AGMs is a little different than people might think of from conventional. So conventional IMU, people are typically thinking like around a mile.
Yeah, so it's shorter distances between the AGMs. Yes, that's one of the requirements to get it that accurate for in our case, and that can easily be done.
Cool. Yeah. So I don't know if you noticed, but around the GRB this year, they had that whole road behind the Hilton torn up, digging up something. Maybe they needed you guys there, because I was like, good Lord. I mean, it was like half the road for at least 100 yards was torn all the way up for whatever they were going after.
And the space next to the hotel. So last night I was hearing them work. Don't. I was like, maybe the high floor would have been more convenient this year.
A shout out the window to those guys. You guys should put an IMU on whatever you're doing. Stop digging up half the road.
Yeah.
Okay. So one of the other things that we talked about last time, and I'm curious to get an update from you on, is, so I always thought the external inline charging was pretty nifty, but you guys have had like the top secret turbocharger, charging going on. Can you tell us a little about that? Where are you guys on that?
Yeah, no, absolutely. This is on the roadmap already for some time, right? So, one of the questions we often get, when we explain what the robot is capable of, we can drive half a mile, and then either you need to recharge it from an additional excavation, 2-inch hot tap, and then you can recharge. You can go another half a mile. The first question you will get, can you extend the range, right? So, we just said, excavations in these environments, urban environments, are expensive. So if you don't have to recharge from the external, avoid the excavation, will cost, hundreds of thousands of dollars, or even millions if you have multiple excavations. So this is a desire and a pull from the industry, and we're looking at extending the range, and there's several solutions. So the technology that we have right now with the battery technology that we deploy, the batteries, as you know, will enhance every day. So there are better technologies out there than we have currently in the robot. So that's something we explore to just get more battery power and extend the range of the robot. That's something we look at. Another thing is reducing energy consumption in your tool. Just like in your car, if you use cruise control, you consume less energy than you drive yourself, and that same applies for the robot. So if you can do autonomous driving by the robot by himself, and when you have a camera in front, you have laser in front. If you recognize the geometry of the line, you don't have to operate it maybe directly from the outside anymore. You stay in control, but you can autonomously let drive the robot, consuming lesser energy, increasing the distance. So that is one of the solutions, and the turbocharging that you like to talk about.
We're anxiously awaiting
Generating energy while you're in the pipeline, by using maybe a turbine, what we call energy harvesting in the line, is a solution that we already have in prototyping, and we are testing at the moment. So that might come on the market at some point. Can't say when. These are certainly solutions because we go in the pipeline. Without a tether, it's wireless operated. So you want to be 100% sure. You want to build in redundancy. You can't let the tool fail or shut down in the pipeline,
right?
Because then it definitely gets stuck. So,
and in all fairness, what's interesting, Rienk, is IMUs are most often the most power-hungry technologies on the tool. And so if you were to think of like what is the most limiting device, it would be, hey, while it's great we're bringing IMU onto these tools, it's also like, okay, now you got to scratch your head and say, how are we going to do this? So this whole idea of like energy harvesting while it's on stream can begin to offset the cost, the energy cost of the IMU. So
we have 50% bypass on the tool. So, the time in the pipeline doesn't really matter, right? So if it takes a couple of hours to recharge the tool just to stay there, and the flow of the gas will let the turbine spin and generate energy to recharge the batteries, that could work. So that's basically the principle. And again, we have prototypes, we are testing, so it is not that we have to start from scratch. So that will be the way forward to extend the range.
We're gonna have to talk about that again next time we bring you on. Next time you bring you on, you've got to give us an update on the turbo.
Looks as cool as it sounds.
With the small videos, like somehow because you have a camera, find out how to like.
It's like the turbocharger in your car when you punch the gas, it like spools up.
Yeah, that would be super cool. Hey, that's innovation. We love it.
The robotics makes people exciting, right? That we can see.
It is pretty cool. That's why I say it's like you think about the advancements in free swimming tools, and there's advancements. Don't get me wrong, but I don't think that they have like quite the shock value and allure that some of the robotic stuff does. Right? Like instantly, as you started describing automated driving of the tool, I started thinking like, oh man, that's probably an area. I'm not saying. Probably an area where you can start to grab onto AI, right? As AI starts to recognize things.
Have to say it in every podcast.
No, but it's capable of.
It's fine.
I'm not even an AI fan.
I endorse it. It's fine. Go.
I'm not an AI. I don't. Every time somebody uses machine learning, I'm like, that's a great way that you represented Y equals MX plus B. That's not machine learning. But no, in this context,
it's all about application. It is if you apply it that way. Okay. Yeah. If it's an Excel, it's not. It's linear regression. If it's in an algorithm for some kind of software where you're implementing a routine, that's AI.
My point was it opens up cool doors. I'm not saying that Intero's looking into that, but
robots are cool, Rhett. Okay, that's
robots
it.
Cool. Got it.
But you have to realize this is not as straightforward as free swimming tools are. So there is a lot of testing involved before you send something in a pipeline. Like I said, there is not a tether. You can't pull it back if something goes wrong, or you just increase the flow and you push it out. So certainly with these kind of developments, yes, we are working on this already for years. But before you really will launch it as an accepted tool in a pipeline and a proven tool in a pipeline, it takes time.
Absolutely.
The word that comes to mind almost is reliability. We think of
it's got to be highly reliable.
That's what I'm saying. When you think of like free swimming ILI tools, I would almost say we're almost a bit spoiled now. Where it's like, hey, we know how to get free swimming tools in and out of pipelines. Right now, occasionally there's always some kind of like catastrophic event where like, oh no, what
it goes 30 miles an hour and shoots into a bin.
Yeah, that's what I'm saying. I mean, it maybe even blows through a door, unfortunately, and God bless those people. But the whole point is like, with you guys, like reliability, like you say, it really is a big issue. Like when we talk about testing and development, like you guys, I mean, really think like fail safe, and that's a big component of it.
But that's in the development, right? How you design a tool, but when you deploy it and in between projects, how you do preventive maintenance and all the procedures is super strict. I always say to the people that operate our tools and the engineers that do the maintenance, like flying a plane, right? So you have, if something goes wrong, it goes awfully wrong. So you need to be very disciplined, very strict in how we do preventive maintenance, how we operate the tools.
First run success is 100%.
Absolutely,
Oh my God, what a question. What's your first run success? What do you mean the tool came out? Like, what are we talking about here?
Every time. You said something actually in that last thing that made me chuckle a little bit, which is just, we started off and it was a half mile, and the first question they asked is, can we do longer? I think the industry is always going to ask you guys for more. Like, I don't think you're ever going to get to a point with your technology and probably the next decade on robotics where they're not going to ask you for more. Can we go further? Can you add this technology?
There's always room for growth.
Can you add
right?
that technology? Can you do this?
But if you go unlimited length, we might be able to replace freeze framing tools, right, with our robotics.
Yeah.
But I mean, Rienk,
Rienk, let's be clear. I've got at least one pipeline, the longest one I've ever worked on, 600 miles.
Yeah,
I don't know how
recharge in the line, it maybe takes a while, but we get there.
I need that tool for the next 3 years. And
different model.
No. It has its specific sprays, right? So that was my analogy the last time. Pizza restaurants and a la carte. We are a la carte company.
For sure.
Right? It's every project is special, and we have special tools. And it's not repetitive commodity.
But once you do it, they're going to want to extend that a la carte. Well, you did that. Can you do this? So I'm curious, if you don't mind, in the last couple of minutes that we have, where do you see you guys getting pulled in the future, right? Because I'm sure that they're not done pulling on you, and I'm sure they're pulling on you for new things. With what you'd be willing to share, can you tell us a little about where you see maybe Intero getting pulled in the future?
Yeah. Now, the range extension is the biggest. I think added value if we can make that happen. We constantly work on improving sizing accuracy from what we do. AMFL, CMFL circumferential is obviously an ask. Improve it. Improve the liquid capability of the line is another one. So we face sometimes liquid in the line. So we have that was another. Actually, I didn't even mention it. We have released a liquid capable tool, so we can have some liquid in the line, and it will not shut down the tool.
This liquid in the line. Help me understand liquid in the line, because you're not talking about liquid products.
Not liquid lines, no. But even in gas lines, you have a certain amount of liquid moisture in the line. So the tool is not fully marinized, so we're not able to go in a liquid pipeline. Although that's an application area as well. The advantage of this tool is you can go quickly in and out, right? Yeah. You don't have to bring pumps, frac tanks, or pump spreads to be able to push and launches and receivers. You can just drive in. So for short lines, also in the liquid space, you would be able to use these robotic tools as a solution for short pipelines, for example, in tank farms.
I was literally went there. That was the first thing I thought of, because that is such a difficult to inspect area.
Exactly. So that's the space where we're also in, right, with our UT tools. But be able to run a UT tool in such an environment, you have to bring quite a spread to be able to do that. And if the line has a certain length, that's okay to do. But there are short distances, then these robotic technologies could potentially be in solution as well. But that's really further down in the roadmap. I think the other enhancements of the tool that I just mentioned, range extension, improving sizing, those are really the first ones to look at.
Well, the cool thing is, like, you guys have such a long runway, right? I mean, unfortunately, obviously, you're informed and kind of pulled by NiSearch, which is neat. But again, I just go back to the modularity of what you guys are doing. Like, you guys can always break into things like, okay, well, hard spots is a big deal. Okay, well, we develop a calibrated low field MFL, and like, just obviously as you guys are figuring things out, it's neat to watch how you guys are addressing like one thing at a time. And it's very tactical, right? It's very specific. It's very niche.
Industry driven, right?
Yeah, like, and it's like you guys are pulled like very specifically. And it's just, my point is, Rienk, it's really neat to watch what you guys are doing.
Yeah, no, absolutely. You hit the nail on the. How you call it?
On the head.
On the head. There you go. Yeah, no, absolutely. You're mentioning a few other opportunities as well. And again, it's not difficult to develop the roadmap for a tool like this.
Yeah, the runway's long for you guys.
Yeah, so we really appreciate the cooperation that we got with NiSearch and also directly with the industry, because they make it happen. We have direct input from them what their requirements are. So, and as soon as you have like the 10-inch example that we started off with, you develop the tool with direct input from PG&E in this case, and you have a test case to deploy it immediately. So that's a very steep learning curve, but that's ideal.
And the reality is, I mean, one of the things I appreciate, like the service that you guys offer, is it grounds us a bit, right? Like I said, we're so used to saying like, oh, we just made this line pig and we put a free swimming tool in there and we just inspected 30 miles. And us often, we'll hear operators, like at PPI, we were recently there, you'll see operators, they do like a graph for like, hey, we have this many thousand miles of pipe, this many miles of HCAs, and this % is piggable. And all that other stuff that we normally don't talk about is what you guys are taking head on. It's like, hey, we're going to help you guys, even if it's a little bit, but we're going to target HCAs, right? We're going to target MCAs. We're going to target those areas of higher consequence. And so it kind of grounds you a bit to be like, wow, man, this is a good effort, right? We always talk about putting dollars where we think they matter the most. And you said earlier, we're inspecting urban areas. Like you said, New York, but same thing like PG&E, Northern California. It's very urban, very hard. And you guys are, again, talk about putting dollars where you're reducing the most risk. So again, it's fun to watch what you guys are doing.
So, Rienk, I want to say thanks for joining us and coming back on the show. Look forward to talking to you guys in a couple more years and hearing about what developments you have. As well as maybe if your food tastes have stayed the same. So again, audience, you heard it here first. Rienk isn't into pizza. It's actually brisket that he's into, and specifically Texas-style brisket is what I heard there. So if you take him out to dinner, take him out and get him brisket. No, but seriously, thanks for joining us. Really appreciate you having on the show. And to our audience, thanks for listening. We'll be back in a couple of weeks. And cheers from Pipeline Things.
This episode of Pipeline Things was executively produced by Sarah Etier. Special thanks to our guest, Rienk de Vries, who joined us from Intero. And this episode was shot at the Post HDX. My name is Christopher De Leon, and I'm not trying to talk like Batman. I just need to get better. It's really hard to talk like Batman.
No, it's not.
I am Batman.